If you're a weather enthusiast, and since you're listening to AMS on the air, I think there's a very good chance that you are, then do we have some exciting news. A global community of weather enthusiasts is waiting for you. The AMS Weather Band, a new initiative by the American Meteorological Society, is a vibrant online community of radar watchers, double rainbow hunters, teachers, learners, and everyone in between. Gain cutting-edge insights about the weather that interests you the most. Share your love of science from wild weather stories to jaw-dropping photos and videos. Gain exclusive access to weather experts, plus lots of fun content and interactive features. Learn all about it and join today at weatherband.org.
Welcome to AMS on the Air. I'm Jeff Rosenfeld.
I am Irene Sands.
And I'm Dakota Smith. We're ready to podcast about all things weather, water, and climate.
The different variables that go into the forecast and the different nuances is a challenge that I absolutely am driven by.
When you are lowering air pollution in your community, in your neighborhood, your community is going to be healthier. I mean, the research shows that you have less visits to the hospital, so there are also positive impacts for your community.
Hello, and welcome to AMS on the Air, the official podcast of the American Meteorological Society. On this episode, we're featuring an interview from the 2020 annual meeting in Boston. I had the pleasure to sit down with Jeff Beamish, Hilary and Patrick Zahn, three atmospheric scientists with a focus in air quality monitoring and forecasting. At the time of the interview, all three worked for Sonoma Technology, an environmental consulting firm based out of Sonoma County, California. I really enjoyed this interview, and I hope you do too. All right, so tell me about, first of all, where you work. Because you're all three from Sonoma Technology.
That's
right.
Yeah.
I think I've seen your podcast on Twitter before, but this is the first time I've heard of Sonoma Tech, I think, because I actually don't think I linked it together.
Right. So Sonoma Technology, we are an air quality consulting firm. We're based out of the North Bay in San Francisco, Petaluma, California. Shout out, right?
Yeah.
Or Chickaluma, as some of the locals call it.
I've never heard that.
But it's a beautiful area. Nonetheless, we have many different hats in the ring, right? So all three of us, we are operational forecasters for a variety of clients across the country, and we forecast for ozone, PM 2.5 and PM 10, smoke and dust in the general sense. On top of that, we have some refinery work as well. We oversee some installation of open path and point source monitoring, and then develop the user interface website for people to check out. I believe we have 6 websites. Patrick, is that right?
That's
6
right.
Websites up for some of the refineries in California?
And okay, so then tell me about the podcast as well, because that was sort of the link, I think, when you sent me a message about chatting, was that you wanted to spread the word about this podcast.
And I don't think that an introduction to the podcast, that I can do it justice, because Patrick was the one that not only kind of crafted the podcast, but really sold me on the podcast prior to my arrival at Sonoma Technology. That got me really excited. So I'm gonna step away and let Patrick take care of it.
The thing was, since we're forecasting for several areas across the country, and we're also looking at all of this hourly air quality data across the world, there were so many interesting things happening with air quality every week, almost every day. In addition to the high-profile episodes like fires and dust storms, there are just things that are interesting to us, our forecast clients, that we see, and we just wanted to share that with people and get people more aware of what's happening on a weekly basis with air quality, especially in the U.S.
Yeah, it's fantastic. Okay, so here's a random question about air quality. I know any place can get bad air quality, especially cities. What's the worst place in the U.S., would you say?
It's funny because, 3 of the 4 high-pressure podcast members, by the way, are here today. We have a 4th that's at Research Triangle Park in North Carolina, helping out EPA with some work. And he, I believe, brought this up.
He's the trivia guy.
He's the trivia guy.
Nice.
So you're like kindred spirits with Marcus.
Nice, okay.
So we had this discussion, actually, on, I think, episode 2.
Yeah, we were talking about ozone.
Yeah, we did a podcast basically talking about just the basics of how ground level ozone forms, why it matters, why it happens over the summer, and that got brought up. And I believe he said 8 of the 10 most polluted cities are in California.
That's right.
And one of the worst is probably Bakersfield. I wanted to highlight that. So that's a city in the southern San Joaquin Valley. And they can have bad ozone or bad PM. It sort of depends on the season. But there's several factors that play into why they have poor air quality there. One of the main ones is really the terrain. They're blocked on 3 sides by high terrain. And then to the north, they can get transport all the way down the Sacramento Valley into the San Joaquin Valley. There are a lot of emissions there. It can get baking hot in the summer. So with the emissions, the precursors to ozone, plus the sunny hot conditions and the terrain blocking, basically just creates this soup of pollution, really high ozone in the summer.
Ugh, it's no fun.
Yeah, and you can see some of that in other parts of the country that have a similar setup. Areas of the south coast of California as well.
Yeah, San Bernardino jumps off the map for me.
Sure, but there have been significant emissions reductions in the last 30 years, especially, that have made those episodes more and more rare. Even since I started forecasting, I've seen fewer high AQI days, AQI being the air quality index.
And you're a Southern California native as well, so you grew up in the region, you're very familiar with.
So I know what high ozone feels like, and it's not nice.
Yeah.
So are places that have problems with PM typically places that also have problems with ozone, or not? Or is that not the case?
Not necessarily. So it depends on sort of the seasonality of the pollution in each area. And what I mean by that is there's some areas that might have only a summertime ozone problem, but maybe their PM season, as you would call it, would be the winter. There are other areas where PM could be high any time of the year. And it really depends on the location and the local and regional emissions, and also the meteorology for that area. So one example that I think of is Sacramento. So they do have a summertime ozone problem. They also have a wintertime PM problem. What's interesting about Sacramento is that roughly half of their wintertime PM can be due to residential wood smoke. So just people burning in their fireplaces. 'Tis the season, I guess, but it can be a real problem. And so one thing that we help with the local agency there is calling burn bans. So if we issue a high AQI forecast, they will try to curtail burning to reduce that residential wood smoke and bring the PM levels back down.
Wow. And with ozone as well, too, their Spare the Air program also has a bunch of messaging. They spend a lot of money on advertising to get that word out into the Sacramento metropolitan area to help people stay off the roads, to reduce those emissions, to cut down on the formation of ground level ozone.
Yeah, we have a winter ozone problem in the Colorado Rockies, in the Front Range.
Oh, sure.
Yeah.
This is something very interesting that we have noticed not only there, but also into portions of Utah as well.
Uinta Basin?
Yes,
Yeah.
which is going to be a future podcast topic for what it's worth.
Okay.
Yeah.
That's right. We have a running list of a few dozen potential topics.
Probably more than a few dozen.
Yeah.
Well, what's the mechanism there that causes the wintertime ozone problem?
Certainly, there's still a lot of research that needs to be done, but I think one thing that people are pointing at is just the photochemistry of the sunlight reflecting off of snowflakes. I believe that is part of it.
Oh, I had no idea.
Yeah. So if
Right.
it's covered with snow, you're getting really like double photolysis, really. The other thing is, again, terrain blocking. So they're in a basin, and that has really 2 impacts. You get buildup of pollution that's not going to exit the basin, a lot of precursors again. But the other factor is often you will get cold air sort of coming down the terrain and settling in the middle of that basin, and that will produce a very strong temperature inversion. And a lot of times we think about wintertime inversions affecting PM, but in this case, it traps all of those ozone precursors in the lower levels of the atmosphere, and it's not going anywhere. Then you get all of that sunshine on the snow cover and wintertime ozone.
No.
I noticed that one of the cities doesn't meet their standard that they're supposed to meet by what is that, EPA or
Right.
And it seems like there's nothing really happens. They get a fine or something, and then there's not any change. This might be a little out of your realm. It's policy based, but I'm just curious, what are things that can actually be done on that type of scale? Because it's not, you have to do it at a scale, right? You can't just
Right,
one
yeah.
person?
So one of the things that I think comes out of that is potentially an air quality forecasting program, like the programs that we forecast for. So if an area is out of containment or isn't meeting the federal standard for ozone or for PM, a lot of times the region is, I don't know if it's forced or encouraged, but to implement some kind of an air quality forecasting program to educate its residents, to help try and bring down emissions, and then to bring the area back into containment.
So one program that has been, I think, really successful is Sacramento's burn ban program, because it's one of those cases where getting the word out about air quality and the upcoming forecast conditions can actually influence the behavior of residents, and that can have an influence on air quality. So it's a really direct connection between people's behavior and the resulting air quality. And if they can reduce their emissions, they're going to be able to breathe easier.
All of this comes back to, protecting human health. It's not really just about, being in containment for containment's sake, but, when you are lowering air pollution in your community, in your neighborhood, your community is going to be healthier. I mean, the research shows that you have less visits to the hospital. And, so there are also positive impacts for your community when you lower air pollution.
Yeah. Okay, so why air quality? Why did it attract you three? It's probably a different answer for everyone, but yeah, why was that thing? Why did that become your passion and your career?
I guess I can start. So in grad school, I studied atmospheric science, and one of the most interesting classes that I took was on atmospheric chemistry. And it just seemed like a really interesting application of the meteorology that I had learned. Then also, as we mentioned, since I grew up in Southern California, I had been exposed to poor air quality. I was interested in doing something about it.
So for me, I think the public outreach aspect, anything that can help out with air quality forecasting and public outreach, that really drives me. I used to be in television. I worked at the NBC station in Tucson for a decade. And so I have experience with the public outreach, and something with air pollution, what I noticed, at least on the TV side now, is, in that field, was the things that would get the most traction messaging-wise on Facebook or Twitter. It'd be monsoon thunderstorms, but air quality. So that always really intrigued me. And the different variables that go into the forecast and the different nuances, it's a challenge. It's a challenge that I absolutely am driven by on a day-to-day basis, because it's not uniform across the entire country, right? Because the terrain's not uniform, temperatures aren't uniform, emissions aren't uniform. So every day is a forecasting experience and challenge that I love taking on.
Yeah, and for me, I would say that I was actually looking for, I have a background in atmospheric science as well. I didn't actually have a lot of air quality education in school. And so when I graduated, it was really looking for these opportunities to work within my field. And I came across a job ad from Sonoma Technology. And I thought, I've never heard of this company before, and looked into what they do on their website and thought, wow, this looks like, they're doing really impactful work that will improve people's lives. And after having been in this community now for almost 10 years, I love how intimate the air quality community is. It's a nice niche or subset of the broader field of atmospheric science. But yeah, doing that really impactful work is what I love.
That's great. Jeff, you mentioned you like the challenges. What's one particularly hard thing to forecast, or what's a forecast problem in air quality that you've seen?
Forecast problem in air quality. I would say there are many, but trying to track emission sources down and their roles and the day-to-day variations is very difficult, and that is something that we have noticed with a few of our forecast clients as well. How something can happen in the United States with emissions, but yet south of the border in Mexico, they can impact those emissions and the air quality as well, where they're not tracked as well. So that is a challenge, and really something that we have looked at in depth and continue to look at in depth to basically get better knowledge of what we're forecasting for and how to forecast it better.
Yeah, so sort of following up on that, I think forecasting air quality is like adding another layer of uncertainty on top of an already uncertain weather forecast. And if we don't have great knowledge about the local sources, it can be really difficult to get the forecast right. And one type of source that we might not be able to detect is a local fire, just a really small scale fire that doesn't show up on satellite detections of fire locations. That can be really difficult. I was going to say there's one meteorological challenge that I've encountered a few times that can really throw off a forecast, and that's just mixing, and especially summertime mixing when it gets really hot. For instance, in Imperial Valley or Baton Rouge, Louisiana, and we've areas like that where you are looking at mostly sunny skies and it's really hot, and so you're thinking, okay, ozone is going to go off, and maybe the winds are pretty stagnant too, so there's going to be an accumulation of pollutants. So you might call an air quality alert, for instance. But if you don't have the stability quite right, or if the models didn't quite get it right, you might, for instance, develop afternoon thunderstorms. And not only will that produce clouds and shut off the input of sunlight that you need for ozone, but it can increase mixing and completely ventilate the atmosphere, so you can see ozone concentrations plummet from 100 ppb to 45 ppb in 2 hours or 1 hour, and that can just completely blow your forecast.
And it's not just thunderstorm development, it's just cumulus development too. That can do the same thing. Yeah. You can get that fair weather cumulus and enough instability going where it can hinder ozone development.
Are there any new sorts of like emissions or air quality problems that you've, I don't know, like maybe it was something you weren't looking for, but you're like, oh gosh, this is actually a little bit of a problem. Maybe like on a local scale.
Maybe the one thing that I can think back on, it goes back to something we talked about with a representative from NASA yesterday, is the effect of the Saharan air layer on ground level ozone development.
Oh, this was interesting.
This was very interesting because of the tropical characteristics basically hindering ozone development. So you can be super duper hot, but if you have the Saharan air layer moving in, ozone doesn't quite develop nearly as much as it should, not because of dust, but because of the tropical characteristics and the long travel it took from Africa all the way across the Atlantic and into the Gulf Coast states.
So tropical ozone over oceans can be as low as 10 ppb when normal background over the US is probably 35 ppb. And we were kind of confused by that, seeing this warm air mass being transported across the Atlantic into Louisiana, for instance. And so we would see the dust, but then we'd see really low ozone. And we thought, well, maybe there's enough dust that it's blocking sunlight, but that wasn't quite right. It was just a different air mass that was a low ozone air mass from a low ozone origin.
Wow.
Yeah. And to credit that, by the way, Ryan Stauffer at
Twitter
NASA.
follow.
He's terrific, and he's one of the better, if not one of the best air quality messengers that we do have on social media. So obviously from us at Snow Technology, huge thank you to all of his work that he does with NASA over at Goddard. But that was something that he had told us about here at AMS, which, the more you know, right? That's why we all attend these events.
Some of these processes are absolutely fascinating, and you all bring such enthusiasm to the topic. So I appreciate you coming. And if people want to listen more about air quality, High Pressure Pod, you want to give yourself some plugs?
So first off, if you want to see some of the amazing work that we do at Sonoma Technology in the North Bay of San Francisco, sonomatech.com. Secondly, to listen to the podcast, you can follow us at High Pressure Pod on Twitter. We are on Apple Podcasts. We are on Spotify. I believe soon we will be on Amazon Alexa, so you can say, Alexa, I want to listen to the High Pressure Podcast.
I didn't know that. That's awesome.
The wheels are still in motion on that one as well. So plenty of places to track us down and listen. And please like and rate.
Nice. Cool. Well, Patrick, Jeff, Hilary, thank you so much for joining us.
For the time.
Thanks for having us.
It was a lot of fun.
Really appreciate it.
And that'll do it for this episode of AMS on the Air. Thank you so much to Jeff, Hilary, and Patrick for joining the show. If you want more information about this episode, you can find it on AMS's website, ametsoc.org. And to get this podcast in your app feed, click that subscribe button. And follow us on Facebook, Twitter, and Instagram. We're at AMS on the Air. Thanks for listening, and happy weather.